Okay, so last couple examples. Last couple examples of implicit. First one, it says find the points. Right? Find the points. Points are x, y. Right? A point is x, y. So we need x, y. Might be multiple x, y's. At which the graph has a vertical tangent line. Has a vertical tangent line. Okay? So the things we need are points, or it has a vertical tangent line, where this guy has a vertical tangent line. Okay? So what's the first step? Before we do anything, before we start working about vertical points, what's the first thing we need to do before we can do any of this? We need to find derivative. Yeah, that's the first thing, right? So let's do derivative. Find derivative. Okay? So we got 8x plus 2y dy dx minus 8 plus 4 dy dx equals 0. Okay? That's the first thing. Second thing, we need to find dy dx. We don't have any points to plug in. So we have to find dy dx. Isolate dy dx, I should say. Okay? So anything that's not attached to a dy dx, I'm going to move to the other side. Okay. Factor out dy dx. We get 2y plus 4 equals negative 8x plus 8. So we get dy over dx equals negative 8x plus 8 over 2y plus 4. There's something that will factor out there, right? What will factor out? What can we factor out? 2. A 2, right? A 2 or, yeah, a 2. So we could factor out, if I factor out a 2 from the top, it would be negative 4x plus 4. And then the bottom would be 2, would be y plus 2. The 2's would cancel out. So if there's something that will cancel out or factor out, we always want to do it. Okay. Okay, so we have the derivative. Derivative is done. How are we going to use it to answer the question, to give me points of the vertical tangent line? What are we going to do? How are we going to use this guy to answer the question? We need points. I need x and y. Right? I need an x, I need a y, at least 1 point, because it says points at which it has a vertical tangent line. What do we know about horizontal tangent lines? We've done horizontal tangent lines. What do we know about horizontal tangent lines? It slopes to 0, right? So horizontal tangent lines have slopes equal to 0. They're critical values, critical points. What about vertical tangent lines? How are those different? Well, say whatever the answer is. How? So if something has a horizontal tangent line, slope 0, right? 1 right there. Right? When does it have a vertical? When does a vertical occur?
I'm guessing when the x values are equal to 0.
When the x values are equal to 0, so what will that look like? So I drew a picture of a horizontal tangent line, two horizontal tangent lines. What would a vertical tangent line look like? Yeah, right? A vertical tangent line, right? It would be a vertical tangent line, okay? So, let me draw it again. So if I have a function like this, those are horizontal tangent lines, right? They're called horizontal tangent lines because they're tangent and they're horizontal. What's their slope? 0. Okay. What do you think vertical tangent lines are going to look like? Okay. Same thing, tangent, right? So if a function maybe is like this, we have a vertical tangent line, right? What do you think the slope of the blue line, that blue line, is going to be? Undefined, right? Okay, so let's go back to our derivative. How do I find points at which the slope is undefined? That's when slope is equal to 0, or that's when slope is undefined, right? When this guy is 0. If I have 0 on the bottom, that means it's undefined, right? If I have 0 on top, that means it's 0. So I'm going to set the bottom equal to 0. Y equals -2. Have I answered the question yet? No, not at all. I haven't answered the question at all, right? On a 3-point test, if it's worth 3 points, you might get 1 point. Might get 1 point. I want the other 2 points. So what do I need? If this was worth 3 points and I did this so far, I might get 1 point. Maybe not. What do I need to do? No. Set the top equal to 0 will tell me where the horizontal tangent line is, but the question's not asking me. I could do that, but it's not going to help me get the other 2 points. It's not going to help me get full credit. So how do I get? Let's plug in -2. Okay, let's plug in -2 back to the original. Okay, so the original was 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. I know that y is -2. Okay, so I get 4x squared plus 4 plus 16 minus 8 plus 4 equals 0. Okay. Negative at an x. Oh, sorry, plugged in when I shouldn't have, right? Yep, shouldn't have plugged in there. So that one should stay 8x. Negative 8x. Okay. So we get 4x squared minus 8x equals 0. How do I? Not an x. 4x. Yep. Factor out a 4x. I get x minus 2 equals 0. Okay, what do I do now? 1 second. Good. So let's 4x equal to 0. X minus 2 equals 0. So I divide by 4. Divide by 4. X equals 0. Add 2, add 2. Okay. So I have 2 x's and 1 y. Almost there. I might have gotten 1.5 now. I might be up to 1.5, maybe 2 points. But I want all 3 points full credit. So how do I answer the question? So where are you getting those points from? So I have 1 y value. I have 2 x values. They make 2 points. So we would say vertical tangents at 2 points. 0, negative 2, 2, negative 2. Now I answer the question. Okay. All right. Okay, so now I want you to do number 11. The second number 11. It should be number 12. The one right below it. I want you to do that one on your own. Okay? Okay, so find the derivative. Negative 2x minus y over x plus 2y. Okay. We want the horizontal this time. Just like the last time, the last question, we only looked at the bottom. We made the bottom equal to 0. That's for vertical, because that slope is undefined. This slope is 0. A horizontal slope is 0. So that means we're going to set the top equal to 0. Okay? So when we set the top equal to 0, let's... Okay? Here's my question. What do we do? How do we solve this? Add y to both sides. Okay, so we can add y to both sides. Okay. Divide by negative 2. So we get x equals y over negative 2 or negative 1/2 y, either whatever. Yeah. The way I did this is that I plugged in that x value back into the original. And then you plug it back into the original? Yes. All right, let's try that. Okay, so I'm going to plug everywhere I see an x, I'm going to plug a negative 1/2 y. Oops, no. So x squared plus x times y plus y squared equals 6. So I get a negative 1/2 y, negative 1/2 y. Okay. Negative 1/2 squared makes a positive 1/4. Y squared. Negative 1/2 y times y makes a negative 1/2 y squared plus y squared equals 6. Combine like terms. They're all like terms on the left side. On the left side of the equal sign, they're all like terms. So 1/4 minus 1/2 is negative 1/4. Plus 1 whole is 3/4. So 3/4 y squared equals 6. Multiply, divide by 3/4 or multiply by the reciprocal. Y squared equals 8. Find the square root. Can't use a calculator. You cannot use a calculator, so you can't change it to a decimal. Mm-hmm. Yeah, you have to simplify it. Mm-hmm. Something we haven't done a lot in this class, but you have to. It's one of those skills you have to be able to do. Simplifying radicals, you break down 8. 8 is 2 times 2 times 2. Square roots, look for pairs. Move a 2 out, keep a 2 in. Okay, that's simplified. So we know what y is now. What's x going to be? You've done a lot of work so far, but we've only got really half the answer. Oh, okay, so plug it in down here? Okay. Mm-hmm. Or could I plug it into the original too? Which one is correct? Both? One? None? Could I take this, because I know this is a solid value. Square root of 2 over 2 is a solid value. Could I plug that back in over here? I could. Could I plug it back in over here? I could. Yeah, they're both okay, because they're both true. They're both mathematically correct. They both have x and y's, and they're both mathematically correct. I know which one I'd rather plug it into, this guy down here, because this guy's a lot easier. This guy's got x squareds and y squareds and xy's. The one we found down here is a lot less work to do. So everywhere I see a y, I'm going to plug in square root of 2 over 2. First positive. 2's cancel out. I get negative root 2. Okay, then I'm going to plug in a negative. Negative 1/2 times negative root 2 over 2. The 2's cancel out again, but this time they're negatives. The negatives cancel out. So I get positive root 2. So I have 2 x's and 2 y's. So my 2 x's are root 2 and negative root 2. But I also have 2 y's, right? So I'm going to have some combinations here. Mm-hmm. Yeah, I'm going to have some combinations. Yeah, so let me give myself some more room here. There you go. All four. Because there's two y's that work and there's two x's that work. So we want to be sure that they're all represented. The second one, yeah, you're right. Yeah. Okay. So when you get down to here, right? That's a brick wall. You hit a brick wall. What do I do? Got to be able to think on your feet. That's the difference between a Math 3 student and an AP Calculus student, right? Math 3 students see this, and for the most part, they're like, I'm done. You guys got to rise to that challenge and say, oh, when I see this, wait a second. It's not a number, but it is a value. I've isolated X. So let me do what I was going to do. What I was going to do was plug this guy back in. So let me try that and see what happens. That's critical thinking. That's problem solving. Okay, you got to be willing to. You got to be doing that. Okay. Okay. So last thing we're talking about. Last thing we're talking about in the notes. Second derivatives. Second derivatives. We've done second derivatives before. You had it on the last test. The last test you had second derivative. You had a question about second. No, not the last test. 2 tests ago you had second derivatives. Last test you actually did have a second derivative because I think there was an acceleration question. But so there's nothing new. Okay. Well, to find a second derivative, you got to find a first derivative. So let's do that. Okay. Divide both sides by 2y. You get 2x plus 2 over 2y. You can factor out a 2. They all got 2's. So you can factor out a 2. So you get x plus 1 over y. That's the first derivative, right? That's the first derivative. Now we have to find the second derivative. So I have to find the derivative of that. I have to find the derivative of this guy. Okay. So to find the derivative of that, what am I going to use? Quotient rule, yeah. Quotient rule. Okay. Move this over here, give myself some more room. Okay, so derivative. So if I find the derivative of the yellow, I'm going to use the quotient rule. Bottom squared. Low times the derivative of the high, which is just 1, minus high, x plus 1, times the derivative of the bottom, which is dy over dx. Okay. So this is the second derivative, dx squared, right? This is the second derivative. What do I do now? Let me give you an idea. Can I solve? Should I solve for this guy? So if I were to solve for it, like I did the first derivative, right? What does this guy mean? Not what it means, but what does it stand for? But what does it stand? I know what it means, but what does it stand for though? What is it? What is it? When you see that guy, what does that mean? If you see it on a test, you see it on a homework, you see it on Delta Math, what does it mean? Which one? Is that what I want to find? So if I solved for that guy there, I would be finding the first derivative again. I don't want to do that. That's not what I want to do. I want to find the second derivative. So I'm actually not going to solve for that guy. I'm actually not going to isolate them this time. First derivative, go for it. But that's the first derivative. I don't want to solve for that. But I do know what that guy is, right? Don't I know what dy dx is? It's right there. Let me change colors. Match. Both those guys are the same. So what I'm going to do is I'm going to substitute the same value in. Dy dx is equal to x plus 1 over y. They're the same thing. Substitute the value in. So instead of dy dx, I want it to say, so I have 1 minus x plus 1 times hmm? 2 dy over dx. Where do you get the 2 from? Okay, so let's see. So I got bottom squared, bottom times the derivative of the top, and then the top times the derivative of the bottom, which is just 1, right? Dy dx. Yep, that was the derivative. Okay. Okay. So now we had no more dy dx's. So now we can solve this. Okay. So the top well, we got to distribute the negative first. So I get y minus x minus 1 times x plus 1 over y. Okay. Okay. So what can I do now? What can I do? There's a couple things I can do, but what's one thing I can do? Mm-hmm. Bring down which one? This guy here? Bring down. Oh, move it down to the bottom here? I can do that, yeah. Mm-hmm. So let me do that. See, y minus x minus 1, x plus 1 over, now it's y to the third. What do I do now? Hmm? Take away this guy here? Why? To just take away that guy there? That's a good question. Can I do that? Can I do that? No, yeah, no. That's a good question, but I can't do that because this is a term here. Let's see. Let's see. Where's my thing? Each of these guys would have to have a y to do that. 2 of them do. This guy does. These 2 guys do. But this guy doesn't have a y. And this guy doesn't have a y. So that's not an option. What is an option? That's a good question because I see that. I see that a lot. Not a lot, but I see it enough where try to do that. Nah, I can't do that, but I could do something else. True to property? Mm-hmm. Y minus x minus 1 over y to the third power. Y minus 2x minus 1 over y to the third. As far as I can go. If this is a multiple choice, or sorry, a multiple choice, you're just trying to go as far as you can to match. You're just trying to match one of the guys until you match something. Once you match something, you're done. Okay. All right, so I want you to do the last one now. I want you to find second derivative of that. Second derivative of that. Yes.
So like if x plus 1 was multiplying with the x plus 1 over y, shouldn't we have to like multiply them first and then subtract it? Because
oh, I see what you're saying.
Yeah. Because if we do that, that changes the form.
Yeah, we should have done that. Yeah, we know. I see what you're saying. So we should have. So because this is one term, this is one term, and this is one term, right? So what I did was I broke them up into smaller terms when I shouldn't have. So yeah. So what we should have done. Let me go back. Let me go back. Not sure how much would change, but let's see. So when I did that move, when I moved y, I could have moved y to the bottom. That's okay. So I got y minus and then x plus 1, x plus 1, and then y to the bottom. That move was okay. But what I should have done was multiplied these two guys. This is a binomial.
So if we kept the y up there top, we could have like multiplied it to the y, and it would be y squared minus x plus 1 whole square. These would be like the difference of squares, and then we can take that y squared.
Say it again. So if I leave this y up here.
Yeah. Because then they would multiply to find like negative x plus 1 whole square like over y, and then to get the common denominator.
Okay. So I should say okay. So yep, let's try that then. There's many ways to do this. There's not just one way. This is one way. I'm just taking a look at this way because I've never done it this way, so I want to see what happens. Okay. There's many different ways to get to solving it, but I just want to kind of finish this out to see what happens. So if I were to, so now what I have to do, multiply these two guys. Well, to multiply fractions, you multiply straight across. So I'm going to multiply the tops, and then I'm going to multiply the bottoms. The bottom is just going to be y. The top will be x squared plus 2x plus 1, because it's x plus 1 times x plus 1. And then I get y squared on the bottom. Okay. Well, this guy here, I'm going to need common denominators, right? So that top would make y squared. Okay, so let's see what I would get. So I would get y squared over y minus x squared plus 2x plus 1 over y. Okay. So on top, I would get y squared minus x, nope, because I got to distribute all of them. So I got to distribute the negative, so all of these guys are going to be negative. Okay. And then keep change flip. and then multiply by the reciprocal of the second. Okay. Let's see.
What I did was I didn't simplify x plus 4 whole square.
Mhm.
I kept it that way, and then that was y squared minus x plus 4 whole square.
Oh, okay. So you didn't multiply it out. Okay. Yeah, you could do that too. No, for sure. Yeah. Yeah. So how it's just all about like for these types of questions, it's all about finding the answer among the ones. Which one is the best? A, B, C, D, E. Which one's the best? So let's see. Let me finish this out here. So I get y squared minus x squared minus 2x minus 1 over y. And then I would flip the bottom. That would lose a power. That would become 1. So I would get y squared minus x squared minus 2x minus 1. Okay. Okay, so now do the second one. Now do the last one.
Should it be in 1 over y squared?
1 over y squared. Oh, yeah, you're right now. I totally screwed that up too. 1 over y squared because it's y. So y to the third, right? Which is the y to the third we had before. Yep. There we go. Okay, so so first derivative, this one doesn't look so bad. It's x squared plus y. It's kind of the derivative is just a monomial over a monomial, so it's not that bad. So that makes it nice because our next step is we're going to have to find second derivative. Okay, so second derivative, bottom squared, low times the derivative of the high, minus high times the derivative of the low. Okay. Plug in first derivative. So I'm going to plug in. Those guys are going to switch spots. So I have 2xy minus 2x times x squared over y squared.
Was it minus x squared?
Minus x squared minus x squared.
Times one derivative.
Minus x squared.
Let's see.
Okay, let's see. Let me start from the beginning. Low squared, low times the derivative of the high, minus the high, supposed to be x squared. I see what you're saying. Okay. All right, so now I have 2xy minus, this is over 1, right? So I'm just going to multiply straight across. So I get x to the fourth over y. Okay. All right. But then I need to find common denominators. Common denominator is going to be y. So I get 2xy squared minus x to the fourth over y. How do you multiply fractions? Right there. And then the bottom was right there. Okay. Over y squared. Keep the top the way it is. Flip the second, reciprocal of the second. Two xy to the second minus x to the fourth over y to the third. Now the top you can factor out an x, but there's no need because the bottom, it doesn't cancel out anything on the bottom. The top you could factor out an x, but there's no need because it wouldn't cancel out anything on the bottom. Okay, and that's it. So tomorrow what we're going to do is I have an activity for you guys to do where you're going to practice these. Okay, it'll give you some good practice where you guys can practice on your own. We've done some guided practice. Now I want you to do some independent practice. That's what we're going to do tomorrow. Okay.